So, thank you very. Are we on? We're not on. Okay. Brilliant. So, thank you very much for the introduction. It's my first time in Korea. I'm very pleased to be here. I have very strict instructions from my translator to speak slowly, so I'm going to try and do that. I won't guarantee it. A very brief introduction to me and to Eurotech, because Eurotech's obviously a new company in Korea and you probably haven't heard of us. I'm sadly able to say I've spent more than 35 years working in M2M. I've worked in M2M ever since I left university. Eurotech has been involved in M2M for over 20 years. And as I go through the presentation and talk about how things have happened in the past and what Eurotech is doing now, I'd ask that you remember that we're speaking from a position where we've been doing things for a long time and got the t-shirt. It always amazes me as I go around and talk to potential customers about M2M, how, you know, having that perspective of 35 years in the industry, how acronyms change, how you know, the applications change, but actually how the fundamental problems and challenges remain very similar. You know, so let's start off by looking at what's happened with M2M systems, how they've been built in the past, maybe what some of the limitations on those architectures are for what we want to do going forwards with the Internet of Things. You know, and this is kind of a synopsis of how M2M systems historically have worked. You could think of them as a manager who sits in an office, he phones to a guy in a remote office, says, has anything happened? Give me your status. And as soon as he's finished that call, he puts the phone down, dials the next guy, and spends all day doing that, going around all the guys that work for him and asking them what's happened. To do that, it's worth noting that he actually has to know quite a lot about the devices that he's talking to, the end people that he's talking to. In the case of a manager on a phone, you know, he's got to know what number to dial. He's got to know what language to talk to the remote person in to get any information at all. And one of the historic problems with M2M systems is, of course, if we want to share that information with other systems and other devices, that gets to be difficult because people don't speak the same language. Okay? And what that's meant over the years is that we don't put one control system onto a site, into a building, onto a bus, onto a train, but we put loads of them all doing the same thing or doing very similar things. Just because it's not possible, just because it's not possible or easy for this guy to get information from these sensors. He has to start putting in all of his own, probably duplicating a lot of the core information. And so as time moved on, systems evolved, and instead of it being synonymous with a guy sitting in a room phoning all of his people, we kind of turned that around and said, well, okay, you know what, these systems can work more like emails. Instead of us asking what the status of something is all the time, we'll leave it to the remote devices to tell us when something's wrong. So now this guy is, oops, I've done it again. Now this guy is saying, well, okay, I'm looking at my local process. I've noticed that my temperature has gone above an alarm limit. I'm going to send information in to him to tell him about that. So we can manage our processes more efficiently. We can be quicker in responding to circumstances that happen on site. But still, we've done nothing to say, how do we get that information and share it with other systems in our ecosystem? So we're still having to put in parallel sensors, parallel devices, and we're still not solving this problem of translation. So we need to move away from this, is kind of the position that Eurotech comes from. You know, by doing that, by having these multiple silo systems, that costs a load of money. Some of it's direct cost. You know, we can measure the fact that we've got all these sensors down at the bottom when actually a lot of them are duplicating information, and that's a direct cost. But also, there's all the amount of money we spend on having custom code that's actually connecting these devices and trying to get information between them. And instead, what we want to do is have our systems able to share information between themselves. You know, we need to be able to say we want to focus not on how I move data from this guy through to this guy. What I want to focus in, where can I get value from my data? So I don't want to worry about the device-centric thing of how do I go and talk to that remote device and get information. I just want to have the data available to me so I can start to work out the dependencies between the systems that are operating in my ecosystem, and I can optimize my whole ecosystem rather than just optimizing individual processes within it. So why is that difficult to do? You know, why have we ended up in that situation? Why is M2M difficult? I go around and I talk to a lot of people about M2M at events like this, but also going and talking directly to customers, potential clients about what they're trying to do, what they want to get, how they get value from their data. And at one level, M2M can be seen as very simple. You know, if we're only worried about one type of sensor, if it's only got to talk over a single sort of communications route to one application, you know, and an example might be in this room we've got temperature sensors that are feeding in to control to the heaters to control the temperature in the room. You know, that's kind of a simple problem. You know, everything's contained within the building. I don't have to worry about messy communication lines. I'm not interested from the point of view of doing a heater control system about moving that data anywhere else. There's any number of ways I could do that. And actually, if I want to invent my own way from scratch, it doesn't really matter. Except that this is exactly how we get those sort of silos of automation we were talking about a couple of slides ago. You know, the fact that I sit down and think, well, okay, I'm going to have this business that's going to make widget-making machines, and I'm going to have a nice little app that controls my machines remotely, and I'm going to invent my own way of doing it. That's great, but in the real world, what's going to happen is someone's going to come along in 6 months' time or in a year's time and suddenly want some other data for that system, or is going to want to integrate a new type of sensor. So life isn't this easy. You know, instead, if we're going to generate platforms that can deal with many industry verticals, then we need something that can address connecting over lots of different communication lines. And within that platform, we need to have some level of built-in expertise. Again, you know, the number of times I talk to people about M2M, and they say, yeah, we want to use cellular communications to connect our devices to our host application. We're going to use Windows dial-up networking. We want embedded Windows on a rugged computer. You know, people don't understand that. In those sorts of situations, the cellular connection is going to drop 4, 5, 6 times a day. And more importantly, they don't understand that from the perspective of the devices down here, it's not always obvious that that connection has died. So a device can be sitting on what it thinks is a live connection, throwing data into a black hole, and the only way to recover that situation is sooner or later someone has to jump into a 4x4, drive 300 miles into the countryside so they can switch it off and switch it back on again. Okay? So we need something that has the expertise built in and knows how to communicate over lots of different communication topologies. And we also need something that can handle data coming from lots of different devices. If we're going to build systems that are to do with the Internet of Things, that are to do with systems talking to systems, that are to do with optimizing whole ecosystems of supply, then whatever we put in place as an architecture has to be just as happy moving 2 bytes of data from a temperature sensor as it would be moving a whole load of data from a still frame camera or whatever. So we need to be data agnostic. It shouldn't matter what the sort of data we want to transport across the system is, we should just do it. So what else gets to be difficult? Well, you know, here's one that we see a lot, is that people have put a system in, but all of a sudden they want to export the data into a whole load of other top-end systems. I've put in a system that communicates to an oil and gas pipeline, and all of a sudden someone's realized it might be a good idea if the information from the flow computers could go into the billing system so we could automate billing. So there's whole loads of end-to-end projects that come about that are nothing to do with adding value to the data. They're nothing to do with transforming business practices. The whole project is an exercise in custom code in 2 systems just so we can move data between them. We need to stop doing that, and the way we need to do that is we need to break this dependency between devices and the systems at the top of the architecture. You know, as we were saying earlier, we have all of these silo systems where the information from all of the devices is owned by the guy at the top of that silo. And if we want to get that information anywhere else, we've got to put some custom code in or figure a way of extracting it. What we need to move to is a system which is much more data-centric. You know, our M2M systems need to work in a similar way to how Twitter works, for example. So on Twitter, if I say I'm interested in hashtag Eurotech, then I can put that in, and onto my phone I'll get information about any person, any device that's publishing information on hashtag Eurotech. I don't need to know how many of those people, how many of those devices are out there in the world. I don't need to know whether it's somebody on an iPhone or whether it's somebody on a PC or whether it's someone on a Mac or on a tablet. It doesn't matter. I don't need to know if they're connected through cellular or through ADSL or through Ethernet. It doesn't matter. What happens is I say I'm interested in hashtag Eurotech, and wherever that data has been sourced from, it comes to me and I do what I need to do with it. And that's how we want to construct our M2M systems. We want to make them data-centric, where what we're interested in is I want the data on this topic, rather than being device-centric, where I need to know that's a Modbus PLC sitting at address 37 and the temperature is in register 42 of it. And of course we need to do all of that stuff at once. You know, so it's not just a case of I need to figure out how I'm going to do my communications topology and have this nice component that can talk over different communications media. It's not just about I need to have this transport mechanism that can move data between systems irrespective of what the sort of data is. It's not just about how can I move data between systems at the top of the tree. We need to do all of this stuff at once. And we can't keep doing it like this. We can't take, you know, systems that we designed many years ago that were perfectly good at doing what they were designed to do, and then add stuff to them to try and make them do something completely different. You know, it just doesn't work if we're going to have the explosion in big data that everyone's talking about. So, what Eurotech proposes, amongst with a whole load of others, is that we need to introduce a layer in the middle, a layer of middleware, that acts as an integration platform for these systems. We need to basically have something that can transport data irrespective of its content, that is agnostic about the sort of communications mechanism, and which provides this decoupling between producers of data and between consumers of data. And if we're going to do that, then when we look across M2M systems historically, again, I lose count of the number of times I go and talk to customers, and the first thing they'll tell me is that their industry is different to everybody else's industry. And then, as we have a discussion, we find out that 90% of what they do is exactly the same as everybody else, and there's 10% of what they do that characterizes that's the difference about their industry. So what we need to do is try and find a way of wrapping that 90% of common stuff up into a platform, up into a set of components that people can then leverage and deploy across verticals, just adding their own vertical market knowledge to characterize it as a heating system, as a control system for a pipeline, as a telematics system on a car. So we basically have two components to address that. I'll just go back to here. One is a middleware platform. It sits up in the cloud and provides a whole load of services at that level. But also, and equally important, is a framework that sits down on devices. Why is that important? Well, if we're going to deploy thousands, tens of thousands of devices, then we need to start developing standard ways of talking to them. And equally importantly, we need to develop standard ways of managing them remotely. We need to be able to say to a user, you can take a device with this framework fitted to it, you can deploy it in the field on your assets, and at a later date, you can download applications to it that are going to make it do what you need it to do. We don't want to put something out on a site at day one of a project and have inherently constrained for the rest of its life what that device is going to be able to do. So at that bottom device level, we have the concept of a multi-service gateway. What does that do for us? Well, it provides an edge to the system. It provides a point at which we can interface to existing dumb equipment, dumb sensors, legacy equipment that doesn't talk modern protocols, so Modbus RTUs or Allen Bradley PLCs, whatever it might be, and provides a point of aggregation, concentration for that data, and then handles the publishing of data into the wider system. When we do that, we're going to want to implement efficient protocols to get the information off of the device, and we'll talk about those a bit later. So this is what we have as a device framework. It sits on any of our devices. We're also a couple of weeks away from making it available as open source code for use on third-party devices. If you go and look at the Eclipse Foundation, under a project called Cura, K-U-R-A, then there you'll find where we're open sourcing it. We already have proof points of this on our hardware, but also on Raspberry Pi. We're doing a port through to Intel's new Quark platform, also to Intel's Clanton. What it gives us is basically an abstraction layer. It gives a framework that sits on a device that you could think of kind of like Android on a phone. So if you think about an Android phone, one of you and me could go into a shop now, we could both buy an identical handset. By tomorrow, those handsets would do different things because we're both going to go to the App Store and we're going to put applications down onto it that are of interest to us. If we downloaded an app that was faulty or wasn't compatible with our device, then we could crash that app. But actually the phone itself would stay operational. We wouldn't crash Android out. We can still recover that situation. So that's what we do on devices for M2M systems. We put a software framework onto them based on OSGI, and we add to that a level of foundation services that handle things like connection management. So when I was talking earlier about, you know, a cell phone connection will drop out 5 times a day and it's not obvious to the device. Well, within our system, within our infrastructure, we have that session awareness up to application level, so we know that a device has dropped off the network, and without any intervention from the user in terms of their application code, we'll say that connection has dropped, we'll re-establish the connection, and we'll queue any data that's being published while the connection's missing, so we can send it when the connection's re-established. And that's transparent to a user. So we do that with services that sit in the OSGI stack as hidden things from the application. We add services then for standard interfaces, so things like GPS support, things like standard protocols. So if somebody wanted, for example, to have a Modbus service, then we've got a standard plugin for Modbus. We do things like device authentication onto the network, and we provide device management so that remotely we can get to the device, download apps, upload apps, download the core firmware all over the air. And we make that available, as I've said, across a whole range of our own devices. So the notion is that you write an application and then you pick a device that's purposed in the particular environment that you're going to be running in. So if you've got something that's going to go into a high-end commercial system, well, there's a gateway that's fit for that purpose. You wouldn't want to put that onto a train. You wouldn't be allowed to put that onto a train because it doesn't meet the qualification criteria, but that box does. And from the point of view of user applications, they are the same thing. So years ago, we were involved in some projects for RFID with a company in Germany. And we had implemented a system where we could handle one RFID gate going through a small edge device, work out what was going past that gateway, and send that up to the wider enterprise. It all worked great. And then we got to the second stage of the pilot, and the customer said to us, okay, we've done this on our trucks, and now I want to put it into a distribution center, and we're not talking about one RFID gateway, we're talking about 30. And we said, well, hang on a second. The gateway device that we're using is a little ARM-based thing. It's cheap. It's relatively low processing power. It won't cope with 30 gateways. But what we were able to do was take an alternative platform. So instead of being small, low-cost ARM-based, was large Intel at that time. Pentium-based, we were able to take the application we'd developed for monitoring RFID stuff across a gate, drop it straight onto the Intel platform, and it just ran, and we could do 30 gates. So we'd gone from an ARM Linux environment across to an Intel Windows environment with no application change. That sort of abstraction of hardware is vital if people are going to leverage applications in the age of the Internet of Things. As I say, we're open sourcing the code under the Eclipse Cura project. We've already got proof points on Raspberry Pi. We're doing an a port through to Intel Quark at the moment. And that'll be available for people to put onto their own platforms, obviously. So that's what we've got at the device side. What do we do in the middleware layer? What do we do that actually holds all this stuff together across multiple devices? Well, this is kind of one of the fundamental things that people need to realize if we're going to realize the Internet of Things. The fundamental thing that middleware layer needs to do is decouple data producers from data consumers. Kind of like the Twitter thing I was talking about earlier. You know, if I put in hashtag Eurotech, then I don't need to know how many devices are sending me information. I don't need to know about how they're connected. With our middleware platform, we do the same thing. We use a publish and subscribe protocol called MQTT. MQTT has been around for quite a while. We co-invented it with IBM. So it was originally IBM and our protocol. It's been open sourced for a number of years now and is widely used for a whole load of M2M communications. It's very scalable. We have one system that has 750 million devices connected to it a day using a single protocol. That system's called Facebook Messenger. I just wish we got a cent for every user on it. Unfortunately, we don't. So, the difference between an MQTT publish and a Twitter hashtag is only in the complexity of the topic. So whereas with a Twitter hashtag it would be one level, like a stock level or hashtag, whatever. With MQTT we're able to define a whole hierarchical namespace. So for example, if I was interested in building a business that dealt in the number of people that went to restaurants of different styles in different towns, I could define a topic space that was town/restaurant type/name of restaurant, and then had the payload of data. And what that means is that now from an application standpoint, just by subscribing to data of various formats, you know, if I want to know the number of people sitting in the Lucky Star Korean restaurant in Seoul, I can subscribe to Seoul/Korean restaurant/Lucky Star and get that information. If I want to know about how many people are in all the Korean restaurants in Seoul, then I can go Seoul/Korean restaurant/star and use a wildcard in my subscription to aggregate data automatically. So that's the fundamental difference between MQTT, how it works, and how a Twitter hashtag would work. It's all bidirectional, so although I talk about data flowing from devices up to applications, actually both applications and devices can publish and subscribe. So you can have completely self-contained control loops just by having devices subscribe to data from other devices. So now we've moved things around to being data-centric. Our applications now don't need to know about how a device is connected to the system. They don't need to know that the source data came from a Modbus device or from a dumb sensor that was a 4 to 20 milliamp loop. They're actually going to say, you know what, I'm interested in something like a stock level or what the occupancy is on something, whatever that topic may be, and the data will just come to them for them to do whatever they want to with. We no longer need to know or care about what data is used for. So another way to think about it, you know, in this room there's a temperature sensor that's helping control the temperature of the room. Well, if it saw the temperature rising very quickly, that would probably be useful information for the fire detection system. If it was the middle of the night and it saw the temperature falling very quickly, that would probably be useful information for the burglar alarm system, the intruder detection system. You know, so there are real benefits by putting in place systems that allow us to move data easily between different systems, because actually that's the way we get to the Internet of Things vision, where we start to join together systems from a whole range of different verticals and start to analyze the data to look what dependencies there are between them. You know, so for example, is there a dependency between the number of cars on the streets in Seoul and what the particulate count in Beijing was 3 days ago? Well, there probably is, you know. If it's blowing over and it's smoggy, then probably people get into cars more than they would do if it wasn't. That's kind of an obvious thing. How many subtle things are there where people's behavior is affected by stuff that's going on in seemingly unrelated areas? That's what the Internet of Things gives us. But to do that, we have to decouple data producers from data consumers to make it work. So, the integration platform that we have that sits in the middle is all about device data. It's about moving data between systems in this data agnostic way that we've spoken about. It's not an application. It's not like a SCADA system. It's a platform. You know, what it does is it moves data around. The application is a function of user-specific code that goes down to the devices and that sits at the top of the system to provide that vertical market intelligence. In terms of components, this is what's in our M2M integration offering. So the first thing that the data hits is something called a message broker. That, for those of you that aren't into publish and subscribe, that's the engine that basically sees messages coming into the system, looks at the topic space, and looks at which applications have subscribed to that data. So a device sends a report in with a particular topic space, the message broker says that's of interest to him, 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 and him, and boom, in real time, it goes out to those devices. So we get real-time data delivery through MQTT, pub sub messaging through a message broker. MQTT we've spoken about. For those of you that don't know about it in the context of Internet of Things, it's currently going through the OASIS standards body as one of the emerging protocols for the Internet of Things. And while I'm on that, one of my pet hates, and there was a gentleman who came out and started me off today, is people who ask the question, what is going to be the protocol for the Internet of Things? And the answer is, there is not going to be a protocol for the Internet of Things. And the sooner that we work that out, the sooner we can all move beyond the question. The reality is that there will be 4 or 5 protocols which become predominant, and then there'll be a whole host of other ones that for specialist stuff have a reason to exist. MQTT, we're confident, will be one of the predominant ones. It's been around for 12 years. It's well proven in providing reliable data over unreliable comms, and it's got a huge user base already. But there will be others. The problem with having the persistent discussion about is there going to be one that emerges as the standard, is that stops users investing in systems, because no one wants to back a system that's using something that's going to be obsolete. Okay? So as professionals within the industry, we need to understand there is not going to be one protocol. There never will be one protocol, and we need to make sensible decisions based on what's around, what's fit for purpose, and what has got some legacy and some merit behind it. So, pet hate over. We've spoken about the message broker. That provides real-time delivery of data to any interested application or device as it gets published. Sitting alongside that, we have a database which subscribes to everything. The database is a schemaless NoSQL one, and that is important if we're going to construct Internet of Things systems. The reason that it's important is, again, if you think about how we've done this historically, then these databases used to be either proprietary, which is no use to anyone if we're going to share data, or they used to be based on SQL. SQL databases have 2 problems if you're going to use them in these M2M systems. The first one of those is entirely practical. Just at the time when you need an M2M system to be responsive because something's going wrong and there's lots of messages going about the place, SQL databases don't keep up. And they slow down to the point where they're almost unusable, in some cases under avalanche alarm conditions. Less fundamental, but probably more important, is that if I'm going to put a SQL database out there, I've got to sit down and I've got to design it. I've got to design it at day one. I've got to decide what all the database tables are going to be. And I've got to implement that and put it out there. Once I've done that, if I've got to make a change, then I've got to pay someone to come along and reconfigure my database. Now, you know, my experience of putting M2M systems in place over 35 years is that what I put it in to do on day one is not what it ends up doing 2 years later. And so we need to implement systems that can automatically adapt to what's going on in the underlying infrastructure without having to have users pay money to go reconfigure them. And schemaless NoSQL databases give us that ability. Essentially, this subscribes to everything coming off the broker and uses exactly the same topic space naming convention to store the data as comes off the broker. And so, if I'm a bus company and I'm publishing information about passenger counts, then I'll have a load of topics that say city, bus, passenger count, X. And in 2 years' time, if I decide to open a pizza delivery business, well then I might have some new devices. They might publish on some new topics. The database just says, oh, there's a new topic. I'll store the data under that topic tree with no user intervention. Now, we haven't said anything about the format of the data because we don't care. As long as whoever's publishing the information and whoever subscribes to it understands what the format of that data is, we're just moving it between them. However, we have a recommended data format, and if you use the recommended data format, then you get inherent compatibility with, for example, web services. So one of the things we do in front of customers is we'll pull up Google Maps or Google Charts. We'll point Google Maps or Google Charts at a database that's got live information coming in from a system. And you know what? There's a push pin on your map with the data beneath it. So it gets to be really quick and easy to implement systems. The other reason for using our preferred data format is that we have what's called a rules engine. The rules engine sits there and allows us to put constructs in place that are to do with, if I see X and Y within 5 minutes and the average of this value is something else, then create an alert. And an alert can be an SMS, an email, it can be a database operation, it can be an MQTT publish. So away from the platform itself without any applications to actually get data going. And then finally, we've got a device management console. That allows us to look at the data from a maintenance point of view. It allows us to authenticate users, provide access privileges. It allows us to remotely look at devices and see what applications are down there, download new applications, configure the applications that are running. So, that's our complete platform. It basically provides end-to-end delivery of data based on a middleware layer and based on a device framework. It provides for data management, connection management, application lifecycle management, data delivery both in real time using MQTT and out of the database for mining using standard REST APIs. We provide real-time analytics for debug purposes. And you can kind of think of it like this, you know, communication systems companies, mobile network companies, they build roads. We're FedEx. We move the data around those roads and get it to end user applications. We don't care what's in the parcel. We don't want to know what's in the parcel. We just move it around. And that has 5 seconds to go. So I'm going to stop there. Thank you.